Same idea as the last problem. Let's do this one. Okay, find a power series for this function. And we could do it the old-fashioned way. We would take the derivative and the derivative and the derivative and find the pattern. Pattern found. This looks a lot like this. So we're going to treat it like that and get that out of the way. There we go. So I want this to turn into this. This only works for R values between 1 and -1, represented that way with absolute value. There we go. And also, final answer is going to have this structure right here. From 0 to infinity of a sub 0 r to the n. So if I can force this to turn into that, I will identify a sub 0 and r, find my interval of convergence, and we'll be done. It'll be great. And I'll even dance. Or not. Okay, so switching colors or just drawing on the board in random places. I could do that too. How about that? Let's force this to turn into that. 8 over 5 minus 3x. I want this to have a subtraction there. Mission accomplished. I want this to have a 1 there. Mission accomplished. Every term gets divided by 5. It does not change the actual output values of this function. It just changes its appearance. So 1 minus 3/5 x. 8/5 is my numerator. Therefore, my, let's stay purple. My 0th term is 8/5. We can identify that. My ratio, common ratio, is positive 3/5. Notice the subtraction built into the formula. 3/5 r, not 3/5 r, 3/5 x. There we go. And so now we have enough to start writing our answer. We don't have the interval of convergence yet, but we're going to get there very soon. Final answer, on our way, n equals 0 to infinity, and a sub 0 is 8/5. The common ratio is 3/5 x. So 3 over 5, whoa, make that a 5 now, son. There we go. 5x, we're going to raise it to the n. And then my interval of convergence is, okay, we're about to get an interval of convergence, and it's going to happen from taking this and putting it in right there. So let's scroll up a little bit and work on this. Absolute value of 3/5, wrong color, don't do that. It was purple on the side. My goodness, what was I thinking? Absolute value of 3/5 x is less than 1, sure is. That absolute value of 3/5 x, well, that's just 3/5 x. We're only going to be dealing with positive x values anyway, right? No, but it's still going to work. So -1 and +1, there we go. Let me back up. We are going to only be dealing with positive n values, but the absolute value thing would help me get rid of negative signs that were in there, which we had on the last problem. So we're going to multiply by 5/3, which gives me -5/3 here, and +5/3 here. There we go. We now have our interval of convergence. It does not include -5/3 or +5/3, so green it is. -5/3, +5/3, done. The only hard part is identifying that this is the structure of your actual equation and it corresponds to that, and knowing what the context is. So then they ask you, write power series for this function, and you look at it and you say, that looks a lot like this. That's when you would do this process.